Hello everyone and welcome back to our channel Quaint. Today we are diving deep into one of the most profound mysteries in modern physics. Mystery is there is one question: how do particles gain mass? And to answer this question is only one. Very simple question: due to the presence of Higgs field. Due to the presence of Higgs field, particles gain mass, though not all the particles. Such as if you consider photons, they are massless. Okay, so this is the topic of discussion in today's video. So what happened just after the Big Bang? Means in the earliest moments just after the Big Bang, what happened? A field spread across the universe. A field across the universe. But before that, what happened? Means I am talking about just after the Big Bang, in the earliest moments after the Big Bang. That time particles were there, but they zipped around with incredible velocity, with the velocity of light. With the velocity of light, they zipped around, and they were massless, and there was no resistance at all. So this was the scenario at that time, just after the Big Bang. But as the universe cooled, a field spread across the universe. Okay, and that field is known as the Higgs field. When particles move through this field, they interact, though not all the particles. Like W bosons are there, Z bosons are there, they interact with this Higgs field and they gained mass. How? You just consider, since the W bosons and Z bosons, they move through the Higgs field, they interact with them. If you consider, means just imagine you are running through water and you are running through air. So you know the comparison. In case of water, you will feel more resistance, right? When you are moving through water, you will feel more resistance as compared to when you are running through air. So that resistance gives rise to mass, a feeling of mass. Am I right? So similarly, here also same thing happens. So since you are interacting with water, that's why you are feeling the resistance. And that is analogous to mass. Since you are interacting, and if you do not interact, then in that case, you won't feel that resistance. That means there is no mass. So similarly here, when W bosons and Z bosons interact with the Higgs field, while moving through that field, they gain mass. Okay, but photon particles, they do not interact with Higgs field, and therefore photons are still massless. Photon particles, you know, those are massless particles. So this is the reason behind gaining mass. Question was what? How do particles gain mass? The reason is due to the presence of Higgs field and due to the interaction of the particles with the Higgs field. If the particles do not interact with Higgs field, so in that case they would not get any. They would not gain any mass. Okay, and this theory was actually proposed in the 1960s by physicists, including Peter Higgs. So that time it was only in the theoretical level, but everything changed in the year 2012. Yes, just 13 years back. At CERN, at CERN, Large Hadron Collider, or LHC, is there. So experiments were conducted using LHC, or Large Hadron Collider, and they found the existence of Higgs boson. Scientists found the existence of Higgs boson, and that was possible due to the presence of the Higgs field. Hence the theory was confirmed. Okay, you know Higgs boson. Anyway, so I was talking about only the topic how do particles actually gain mass. So reason is, it is due to the presence of Higgs field. That means what? We can conclude this way, that if there would be no Higgs field, in that case there would be no atoms, no stars, no planets, no life. So universe as we see it today is just due to the presence of this Higgs field. And due to this discovery of Higgs field, we came to know the difference, the subtle differences there between electromagnetism and weak nuclear force. Okay, you know weak nuclear force. It is found in a radioactive decay process. Okay, weak nuclear force and electromagnetism. So before the spreading of the Higgs field, they were unified force. Both the electromagnetism and the weak nuclear force were unified force. But you know electromagnetism, that is due to the photons, and weak nuclear force, that is due to those bosons, W and Z bosons. So W and Z bosons gained mass due to the presence of Higgs field, but photons didn't interact with Higgs field, hence they gained no mass. Therefore, at present we can see the difference between them. Reason behind the difference, though the difference is subtle, but difference is there. The difference we can see today is due to the presence of Higgs field and the interaction. In one case they interacted, in other case, means in case of photons, they do not interact with the Higgs field. So we can easily say that once, means during the Big Bang or just after the Big Bang, they were actually unified force. Okay, but at present they are different. Anyway, so this was all about today's topic, how particles gained mass, okay, due to the presence of Higgs field. Means topic of discussion was actually Higgs field and its importance. So you can easily conclude that due to the presence of Higgs field, everything has become possible. The universe at its present condition, or you can rather say that we are living in this world due to the presence of Higgs field. Our existence is because of the presence of Higgs field. Anyway, so this was all about today's topic, and if you found this fascinating, so please like, share and subscribe to our channel, and this is the end of this video. Thank you for watching this video.